So you're looking at that calendar, and whoa, the Algebra 2 Regents is coming up pretty soon. Now, I'm going to be creating a study guide, or just a series basically covering all the units in Algebra 2. And along that, I'm probably going to be doing Algebra 2 Regents as well. So make sure to check that out. Now, Algebra 2 might seem really boring at first, but a lot of the concepts in Algebra 2 are used in calculus, and calculus has a lot of real-world applications, like in physics, engineering, and computer science. Now, if you're ready to get them brain cows milked, let's get to it. A polynomial is an expression made up of variables and coefficients, where the exponents of the variables are whole numbers and the coefficients can be any number. So first of all, let's just talk about what an expression is. So if you have something like 1 plus 1 is equal to 2, this would be an example of an equation because it has an equal sign. However, if you just have 1 plus 1 and there's no equal sign, this would be an example of an expression. So polynomials, they don't really have an equal sign to it. And some examples of polynomials are, for example, I have one here, 1x to the second power plus 2x plus 2. This would be an example of a polynomial. It's made up of variables, so it has this x to the second power, it has this x right over here, and it has coefficients. So coefficients are just the numbers in front of the different variables you see. So for example, right over here, in front of the x squared, you see this number 1. So you would say that 1 is the coefficient of the x squared term. In this case, right, for this x term, you see a 2 in front of it. So 2 is the coefficient of the x term. Now, there's something known as the leading coefficient. So the leading coefficient. And the leading coefficient is just the coefficient of the x with the highest power. So in this case, right, you can think about just plain old x by itself as x to the first power. And you can think about this 2 right over here as having x to the 0th power. Because x to the 0th power is equal to 1. All right. So 2 times x to the 0th power is the same thing as 2 times 1, which is just 2. So notice how I actually did not change the value of this 2 right over here. Right, this is still the same value as it was before. I just kind of added in this x to the 0th power just to show you how, the leading coefficient is the coefficient of, I just added in this x to the 0th power just to show y'all that, the leading coefficient is just going to be, the coefficient for, the highest power. So in this case, x to the second power is, the highest power in my polynomial. So that means my leading coefficient is just going to be this 1 in front of the x squared. So some other examples, they're all going to look pretty much the same, kind of. So if you have, 4x to the second power plus 5x to the second power plus 6x plus 4, right, polynomials are able to have something known as constants, which are just terms without an x, seemingly. So you can have 5x to the 5th power plus 4x to the second power plus 5. This is another example of a polynomial. And, in this case, our leading coefficient, right, the coefficient of the highest x power, which is in this case 5, is going to, there's another thing called basically polynomial degrees. So the degree of a polynomial. Basically, the degree of a polynomial just represents the exponent, the highest exponent of an x term. So for example, if we were to take a look at this polynomial right over here, the degree of my polynomial would be 5. Because x to the 5th power is 5 right over here is the highest power. If I were to take a look at this polynomial, well, what's my highest power? My highest power is this x to the 3rd power. So my polynomial here would be of 3rd degree. And finally, for this one, my polynomial would be of, the 2nd degree because I have this x to the 2nd, okay? Now, some examples of things that aren't polynomials is 1 divided by x, 1 plus x divided by x, 3 plus x squared divided by x. Polynomials never have division by next term. So if you immediately see that, you're dividing by x of some sort, that is not a polynomial, okay? You also can have negative exponents. So if you have x to the negative 1st power, x to the negative 2nd power, x to the negative 3rd power, these would not be considered polynomials. And finally, if you have x to some fractional power, so x to some, fractional power, this would also not be a polynomial. Remember, polynomials have to have exponents. The exponents of the variables have to be whole numbers, right? So whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, and then goes on to infinity. So the exponents, all of these exponents right over here are whole numbers, right? All of these exponents. Even the constant, right? I talked about it before, but you can think about this 5 as 5 times x to the 0th power, right? So 0 is a whole number, so this would be part of this polynomial, right? So that's pretty much it for the introduction to polynomials. Okay, and what I'm doing right now is polynomial addition. So I'm actually gonna go through polynomial addition, subtraction, and multiplication. Polynomial division, I'll reserve that for unit 4. Okay, so whenever you have two polynomials and you add it to each other, you're basically just gonna combine like terms. So what do I mean by that? Well, it might be better if you these two things up. Now this x to the 3rd power, you're basically adding this to a 0, right? Because there's no x to the 3rd power term in this polynomial right over here. So just x to the 3rd power plus 0 is just going to be x to the 3rd power. Now I have this 2x to the 2nd power, and you can think about this as a 1x to the 2nd power. So 2x to the 2nd power plus 1x to the 2nd power gives me 3x to the 2nd power, right? 2 plus 1 is 3, and you still have this x squared term left. Finally, 5 plus 5 is equal to 10. So basically, in polynomial addition, you're basically just combining, one term with this kind of the same similar exponent term, that it kind of corresponds with in the other polynomial, right? This x squared, you add it up with this x squared. This 5, you add it up with this 5 because they both don't have an x term, right? They're both constants. So you're kind of just matching each term up with the other. Now, polynomial subtraction is basically the same thing. If I have x. Now, in order to solve this, what I'm going to do is, first off, I'm going to distribute this negative sign to all the terms. And in case y'all don't know what the distributive property is, if I have, let's say, 5 times 1 plus 2, I mean, obviously, this is just going to be equal to 15. But, a cool way of doing this would be you distribute the 5 to both these terms. So 5 times 1 is 5, and this is going to be plus 5 times 2 is 10. So 5 plus 10 gives you 15. Basically, in the distributive property, you're taking one term and you're just going to be multiplying it by the rest of the terms inside your parentheses. And usually this is done, when the things inside of your parentheses either has a plus or it can have like a minus, right? And then, you can do the distributive property. So in this case, I'm just going to distribute this negative sign to all the terms. Keep in mind that I have to distribute to all the terms because I have the parentheses, okay? If I did not have the parentheses, right, if we're taking a look at this negative 4x term, we don't distribute this negative sign to all the terms because, well, this negative sign right over here, right, there's no parentheses, right? There's no parentheses out there. So this negative sign just stays put. But if this negative sign is outside of parentheses, that's when you distribute it to all the terms. So keep that in mind. So we're going to have negative times x to the 3rd power is just negative x to the 3rd power. Negative times negative 1 times negative 4x. It gives you positive 4x. Two negatives make a positive, by the way. And negative times 6 is just going to be negative 6. You can also think about this negative sign as negative 1. So negative 1 times this is negative x to the 3rd power. Negative 1 times negative 4x is just 4x. And negative 1 times 6 is just negative 6. And you still have this x to the 4th power minus 2x to the 3rd power plus 5. And in this case, now that you distributed this negative sign, you're just going to put a plus here. You've already distributed the negative counterpart. So like the negative is basically gone. So you're just going to be left up. You're just going to be left off with this addition. All right, and now you know what the drill. So x to the 4th power, there doesn't seem to be an x to the 4th power term in this polynomial. So you're just going to be left with x to the 4th power. Negative 2x to the 3rd power minus x to the 3rd power gives you negative 3x to the 3rd power. Let me see. So you're going to have just 4x. So it's just going to be plus 4x. Because there doesn't seem to be any x terms, so terms with just an x. So in this case, the only thing that has an x is just this 4x. So you can think about it as 0x plus 4x is just 4x. And then after that, 5 minus 6 is equal to -1. And that's going to be our result. X times x to the third power. Well, what you do is you just add up the exponents. So x to the first power times x to the third power gives you x to the fourth power. Let's say if you have 4x times x to the second power, what do? Well, whenever you're multiplying polynomials together, you're going to multiply the coefficients first, and then you multiply the x terms next. So what's 4 times 1? That's 4. What's x to the first power times x to the second power? That's x to the third power. And there's your answer. If you have, let's say, 2x to the third power plus 5x to the sixth, times 5x to the sixth power, what you do is you first multiply out the coefficients first. 2 times 5 is 10, and then you multiply out the x terms next. So x to the third times x to the sixth is x to the ninth. Very similar to combining like terms, like what we did before, right? You combine the non-x terms first, and then you combine the x terms second. Now, what if you have something like x times x plus 1? How would you do this? Well, think back to, one of the examples we did, where we had to distribute this negative sign to all the terms. Well, that's kind of what we have to do here, the distributive property. What I'm going to do is I'm sort of going to distribute this x to both these terms. So basically, I'm multiplying this x by the outside x, and I'm multiplying this 1 by the outside x. So x times x gives me x squared. Right? You can think about it as x to the first power times x to the first power. Well, if, you're just going to add up the exponents, right? Because you have the same base. So you're going to add up the exponents. Remember your exponent property, guys. And then you have x to the first power times 1, which is just x. And there's your answer. If you have, let's say, let's do x to the third power times x to the second power minus 1. What you do is you just distribute this x to the third power to all of the terms. So x to the third power times x to the second power is x to the fifth power, and x to the third power times -1 is negative x to the third power. The examples we've seen before, what we basically did was we multiplied something known as a monomial. And a monomial is basically just kind of one term. So, x to the first power, that's only one term. This x to the third power, that's also one term, right? And what we're doing is we're multiplying this by a binomial. A binomial is basically just kind of a polynomial term, but with two terms. So x squared minus 1, this is a polynomial and it has two terms. If I have x to the first power plus 1, this is a polynomial with two terms. All right, so monomial is polynomial with one term, binomial is polynomial with two terms. Mono, and then you have bi. Okay, so that's how I remember it. Mono means one. Bi means two. Think about like bicep, for example, right? You have got two like main like muscles in the bicep. And then next up is going to be tri, which is 3. So think about triceps, right? Trinomials. So trinomials are, you can kind of guess what this is. This is a polynomial with 3 terms. So x to the second power plus x plus 1. This would be an example of a trinomial. And then, you can go on from there. And, another thing about polynomials is that your exponents can get pretty huge. So if you have 2x to, let's say, the 1,000th power, this would still be considered a polynomial. As long as your exponent's a whole number and, it's not a fraction and all of that, what I said before, well, it's still a polynomial. Now, in this case, what I'm doing is, in this example here, I'm multiplying two binomials together. So how do I do this? Well, remember DDP, double distributive property, is first you distribute the x to both of these terms. So x times x gives you x squared. X times 3 gives you 3x, right? X times 3 gives you 3x. And now what you're going to do is you're going to take your 1 and you're going to distribute it to both terms. And then you're going to take your 1 and you distribute it to both terms. So 1 times x gives you 1x, or just x. And 1 times 3 gives you 3. So you're going to be left with x squared. These two things you can combine together because they both share a common x, right? So 3x plus 1x gives you 4x, and then plus 3. And that's going to be it. You can't combine this any further because this has an x to the second power term, so we can't combine it with anything. This has a 4x term. There's no other terms you see with x, right? So can't combine it with everything. And this term has no x at all. There's no other terms with no x at all, so this is going to be your answer. When you multiply two binomials together, you get a trinomial. Two binomials together, you get a trinomial. And this is seen in this example here, right? Because whenever you multiply this x term by this x term, well, you're going to get x to some higher power, right? X to the first power times x to the first power gives you x to the second power. So you're introducing a new term into this expression where you're multiplying a binomial by a binomial. Let's do another example. If I have x minus 1 times x plus 5, you're going to use the double distributive property. So x times x. So actually, let me just draw the arrows first. So first, you're going to distribute the x's, and then you're going to distribute the -1 to both of these terms. So x times x gives you x squared. X times x gives you x squared. And wow, these are horrible colors. I'm just going to stick with yellow. Okay, x squared. X times 5 gives you 5x. Now you're going to start distributing the ones. The -1. So -1 times x gives you -x. -1 times 5 gives you -5. So 5x minus x is just 4x. So you're just going to be left off with x to the second power plus 4x minus 5. And that's going to be your answer. All right, unit 1 is done.